Okay, everyone, one last time with recognizing the pattern. So I want you to look at the three examples, and then I want you to try and fill in the last four with what you think their derivative is. And then I want you to come back and watch the rest of the video. Okay, so here's what I'm hoping you spotted as you looked through. Things are switched in this one. This time what's always the same is the inner function. 3x to the negative 1 plus cosine x shows up all the way down. And what's changing is the outer function. So in this first one, the outer function is the square root and then the negative sixth power. And in the third one, it's e to the x. It's the outer function, e to a power. And when I look over to the right-hand side to the derivatives, what I see that's the same every time is this inner function showing back up, and then the derivative of the inner function being out here at the end. So that kind of matches the pattern we saw up above, but we're looking now at what's different. And what's different is this 1/2 to the negative 1/2, negative 6 to the negative 7, and then this being exponential. And what all of those are the shortcuts for the outer function. So if we imagine this first one is 3x to the negative 1 plus cosine x all raised to the 1/2 power, what I'm seeing here is the shortcut for something raised to the 1/2 power. 1/2 blank to the negative 1/2. And for the next one, my outer function was raising something to the negative 6 power, so like x to the negative 6, and the shortcut for that would be negative 6x to the negative 7. And then for the last one, it looks a little different, but hopefully we caught on that the outer function is e to the x, so it's its own derivative, and that's why we see that exact same thing show right back up here. Okay, so if we're going to carry this through and fill in the blanks, the next function is that same inner function raised to the pi power. So it's like our outer function is an x to the pi, and the shortcut would give us pi x to the pi minus 1, but it's not just x. So we fill in that original function, and we multiply by the derivative of that inner function, just like we did up above. In the next one, we have that same inner function, but now the outer function is sine. So we're thinking the derivative of sine x is cosine x, but we didn't just have an x. We had a 3x minus 1 plus cosine x, and then we need to multiply by the derivative of the inner function. And then we're asked to go one step more abstract and say, okay, so what happens when you take some function of our inner function 3x to the negative 1 plus cosine x? And what we're seeing up above is that you should take the derivative of that outer function. This inner function should stay exactly the same, and then you should multiply by the derivative of that inner function. And then this one asks us to go one step further and fully generalize. We've looked at what happens when you change the inner function and when you change the outer function. So can we put it all together? And what we set up above is that you take the derivative of f, you leave the inner function g alone, and then you multiply by g prime of x. This is the full chain rule. So keep this, write this down somewhere, keep this handy. This is what we'll be using. You want to add it to your list of things to memorize. Also remember, as you're doing your homework, yes, you have some examples that I've done here and you have some examples that I'll do later, but every single one of these problems listed is an example. So remember, you can go back and look at any of these first three intro parts and kind of see what the pattern is and connect that to the problems that you're working on. All right, next we're going to prove that this really does work, that it is the chain rule, and then we'll just practice with it.